Hello guys, so this is the second lecture and second video also. So from today onward I will apply the techniques of Ebbinghaus. So let's start. So I will study fluid mechanics. Okay, so now my class has finished, so I am now doing active revision. Okay, let's see. First, I have studied what is a fluid. So, matter is of three types. One is solid, liquid, and gas. Okay. So, liquid and gas both have called fluid. Okay. So many students have doubt that liquid is a fluid or gas is a fluid. No, both liquid and gas are considered as fluid. Okay, so let's see. Then fluid can flow. One statement. So fluid can flow. That means flow means continuous plastic deformation. Okay, fluid can flow means fluid can doing continuous plastic deformation. Plastic deformation, you can say change of shape. Okay, permanent change of shape. I will discuss these things later. Okay, we will look after. Okay, so this thing. Okay, and one thing. So fluid cannot resist shear stress under static condition. One thing that fluid cannot resist shear stress under static condition. However, if can resist shear stress under dynamic condition, fluid cannot resist shear stress. That means you can say shear force. You can say fluid cannot resist shear force or shear stress under static condition. However, it can resist shear stress. That means fluid can resist shear stress under dynamic condition. But what I am studying, that is static condition. So here shear stress is not resist. Okay, fluid, that means fluid cannot resist shear stress. Okay, then two things are there. Okay, I already saying that fluid is stationary, fluid is moving. In moving fluid, shear stress is resist doing some shear stress, but in static shear stress is zero. That means there is no shear stress in static condition. Okay, and in sum, that means strength of mechanics, we are studying alpha is equal to shear strength, but in fluid mechanics we are studying d alpha by dt as a rate of shear strength. We are not concerning about shear strength in fluid mechanics. No, only rate of shear strength we are studying, and only strength is studying in strength of matter. Okay, it is a very important thing we have to be learned, or we have to be focus on, or we have to remember. Okay, we have to remember. Okay, there is two things. One is finite process, another is continuous process. For example, if you go into a company, okay, they or you are in a hiring position. Two category in company. If he selected you, he had decided to give you some money. That means like 50,000, which is fixed. But in hiring situation, he can accelerate or he can increases your salary in month wise. That means first month you will get 40,000. After 1 month you will get 50,000. That means continuous increasing something. that is called that is one example. So this example is clearly justified you or clearly understand you that finite process what continuous process. Finite process means fixed amount, some amount is there, that 50,000 month 50,000, but continuous process, that means rate, that means every month we will increase the salary like that, that is continuous process. That is one is finite process and another continuous process. In fluid, it is very very important. In fluid, rate of deformation is more important than what already I said, that in some only shear strain is there. Okay, that point you remember. Okay, so in fluid, rate of deformation is more important than total deformation. It is one very very important thing. In fluid, rate of deformation is more important than only total deformation. We are not, it is not important that total deformation we want in fluid. No, it is, we want rate of deformation in fluid mechanics. Okay, it is very very important. Rate of deformation, we remember this. Okay, that means d alpha by dt changes. Okay, angle change. Okay, alpha means angle change. So I will talk in later. Okay, that's okay. So because fluid, why rate of deformation is more important than only deformation in fluid? Because fluid continues to deform as long as the external force. That means fluids always deform as long as the external force is applied. If there is no external force, then there is no deform will occur in fluid. It is the main thing we have to be occur. And it is very very important. It will ask many times in GATE ESC examination. Okay, so in fluid, rate of deformation is more important than the total rate deformation. And because fluid continues to deform as long as, because fluid always continuously deform as long as external forces. That means external shear forces, that means it is a pain, you will applying external shear stress. So as long as your external shear force in fluid, that momentum time, till that time, rate of deformation is occurring. After that, you will stop where then the deform will stop. It is the main important thing. Okay, then I read one thing I have to do, why it is very very important for question, because many ES exam question you can say you can visualize that, or you can read that. One thing he is always right, fluid continues deform as long as external force. It is wrong statement. I said fluid continuously deform as long as external shear stress or shear force. That shear is more important, because external shear force, that means external force has three types. One is tensile, compressive, shear. So is up to shear force. At the point of shear force, you will stop, the deform will stop. It is very very important. Then let's see some characteristics of solid, liquid and gas. What is the characteristics? One by one we'll see. Response to shear stress. So response to shear stress, solid responses resist total deformation. What? Solid resist total deformation. Liquid and gas resist rate of deformation. Okay, that means response to shear stress, that means you can say solid that is resist total deformation. what solid will do? Solid resist total deformation. So what deformation is doing and shear stress is applying, then it solid can resist deformation. That means now this is a pen. Please listen carefully. Now this is pen. I am doing shear stress, but it is not deformed. That means shear stress solid is response to shear stress. That will not react, but after very large external force, large external shear force, it can move. But now if I doing some little amount of shear stress, it will not move. That means response to shear stress. That means resist total deformation. But in a liquid or gas, that means in fluid, resist rate of deformation. There is not only total deformation is counting with. There is we talking about resist rate of, that is rate word is there. It is the only difference. There is also resist, but there is resist rate of deformation. There is no total deformation. There is rate of deformation. Okay. Then one thing is compressibility. Okay. For solid it is incompressible. For liquid it is incompressible, but for gas it is compressible. Okay. Anyone can think that how liquid can compressible? Yeah, some extent it can compressible. Yeah, but not larger extent like solid. Okay. And what is the actual meaning of compressible? We will discuss in later lecture. Okay. Then ability to form free surface. Yeah, solid can ability to form free surface. Liquid can ability to free surface, doing free surface, but gas have no free surface. If one container, let's see, we do container, that in that container one part nitrogen, one part is oxygen gas, and there is in between these two gases there is no boundary. So that time if you open the boundary, they have that position, there is any free surface? No. So gas have not ability to form free surface. That is the matter. Okay. So this thing. Then another characteristics, ability to expand without limit. It is an ability. What? Ability to expand without limit. Solid no, liquid no, gas yes. What? Ability to expand without limit. That mean you can say this is a solid. Okay. If you expand, it has a limit, but further we extend, it will break. Okay. So that means ability to expand without limit, it has no ability to expand without limit. That means ability to expand without limit, that means it has to be a limit. Solid, and that is also a liquid, but in gas it is yes. So for detail conceptually I will now show you doing a demonstration. Okay, so let's see, it is a cap. Can we, now I am discussing about cohesive force, ability to expand without limit. That means we have to be discuss on cohesive force. These two pens are there. Can I cohesive force, that means you can say it has very attraction. That means it has not ability to expand limit. That means it has always trying to attract with each other. In liquid also same thing, but if you gas, if you situated this, that is very cohesive or is less, so it can expand in that limit. Okay, that is the point. Another thing, ability to resist small amount of tensile stress. Ability to resist small amount of tensile stress. It is solid, liquid and gas. So I am now explaining. So ability to resist small amount of tensile stress. So in solid, yes, so that you can doing something, that means ability to resist small amount of tensile stress. So I am doing, so that it cannot deform. That means it has ability to resist small amount of tensile force or tensile stress. Yes, in solid, yes, and liquid also yes, but gas has no. So if gas will push, or you can just shear, it will move a rapid manner. Okay, so that is the thing. Then last characteristics is ability to confirm shape of container. Okay, so it is a liquid, so ability to confer a shape of container. So if I liquid, this liquid I will put in a glass, that liquid will take the shape of that glass. Okay, so liquid, that means gas, has ability to confirm shape of the container. It can carry or it can take the shape of the container. So finally I summarize the characteristics. Response to shear stress, resist total deformation, resist rate of deformation. It is that means resist rate of deformation, liquid and gas also. Compressibility, incompressible, compressible in gas. Ability to form free surface, in solid yes, in liquid yes, but in gas no. Okay. Ability to expand without limit, solid is no, liquid is no, gas is yes. Ability to resist small amount of tensile stress, yes solid, liquid also yes, gas is no. Ability to confirm shape of the container, solid no, liquid yes, gas yes. Okay, bye. So we will discuss on later. Okay, good.